Can you all listen to me very clearly? Yes or no?
Yes, sir.
Yes, sir.
Okay. So before I start with the things ahead, I will just use this class to show you some things which I cannot show on the whiteboard there. So a bit about spectrum, I will be showing you some slides on that. A minute, please. Can you all see this?
Yes, sir.
Now this is the emission spectrum of white light. Okay. So you can see that white light is being made to pass through the prism, and after passing through the prism, this white light is scattering, it is breaking down into its constituent 7 colors. So a continuous band of 7 colors you can see Vibgyor. Is it clear, the emission spectrum?
Yes, sir.
Yeah. Now this is what I was telling you on that day, that the 7 colors, they are not differentiated, they are not visible boundaries between the 7 colors, and they are superimposed on each other. So you cannot make the visible boundaries. So this is the spectrum of white light. Another image to say it, this is one of the better ways of putting it across. You can see there are 7 colors, but the 7 colors are superimposed on each other. There are no visible boundaries between them. Clear hua ye?
Yes, sir.
Now let me show you the spectrum of sodium. 1 minute. Now see here. Can you see this? Down I have, ऊपर देखना पहले, जहां पर the cursor is moving. Can you see the cursor moving?
Yes, sir.
नो, जो ऊपर वाला है जिसमें देखो you see all the dark space, and उस dark space में just you see 2 yellow lines. और नीचे देखो, again you have a spectrum where you have all colored and you have 2 dark lines. Now one is labeled as A, another as B. So tell me, out of A and B, which one is the emission spectrum?
A, sir.
Which one is the emission spectrum and which one is the absorption? जो ऊपर वाला है वो सोडियम का emission spectrum है, और नीचे वाला is the absorption spectrum. Is it clear?
Yes, sir.
Sir.
ये देखो. So this is the emission spectrum of sodium, all dark, and in that you have two yellow lines. नीचे हाइड्रोजन का है, just ignore that. ऊपर देखो सोडियम का, in all dark you have two yellow colored lines, and hydrogen ka I will be taking in detail. So some emission spectrums here, you have sodium, you have hydrogen, you have calcium, you have magnesium, you have neon. Identify the spectras. किस किसके हैं ये? Identify the spectras.
Sodium, sir.
ऊपर सोडियम का कौन सा स्पेक्ट्रम?
emission spectrum, sir.
एमिशन स्पेक्ट्रम, और नीचे सोडियम का एब्जॉर्प्शन स्पेक्ट्रम. Now I will be coming to the spectrum of hydrogen. That's very important. ये तो नीचे देखो हाइड्रोजन एमिशन स्पेक्ट्रम. Now you can see the different lines. नीचे देखो the Lyman series, which lies in the ultraviolet region. Then you have the Vibgyor, the Balmer series, and after that all the three series, they lie in the infrared region of the spectrum. That is the Paschen, Brackett, and Fund. ये भी देख लो एक बार. So this is how the whole setup looks like. Gas discharge tube containing hydrogen, and electric discharge is passed through it, and then the emitted radiations, they are passed through the slits and then through the prism, and after passing through the prism, they are made to fall on the photographic plate, and on the photographic plate we get a series of 5 lines, which are the Lyman, Balmer, Paschen, and Brackett series. Got it?
Yes, sir.
So this was about the spectrum. Then I did with you the Rydberg's formula. That was clear. Rydberg formula कर लिया था ना हमने?
Yes, sir.
Yes,
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 sir.
sir.
Any doubts on that?
No, sir.
So then I will just be showing you a bit of the Bohr's atomic model. एक बार ये देखो. The fundamental particles, protons, neutrons, electrons, their charge, their mass, and where they are present. So this is how the Rutherford's model looks like. Just have a look around it. It can be compared to the planetary system, right? Center में nucleus के around the electrons are revolving, and the down we have the planetary system where the sun is compared to the nucleus, and the planets, they correspond to the different electrons. What the problem with the Rutherford model was the revolution of the electron in a circular orbit is not expected to be stable. Why? So because I told you that electron being a charged particle, and during its motion, it will be losing energy, and slowly it will be attracted by the. So any particle in circular motion will undergo acceleration, and during acceleration, charged particle will lose energy. And as the charged particle will lose energy, so the atom should be highly unstable, because the charged particle will lose energy, and slowly it will fall into the nucleus. Is it clear?
Yes, sir.
Yes, sir.
Then was the spectrum, which we have discussed in quite detail. Then came the Bohr, a Danish physicist. He successfully explained the spectrum of hydrogen. How was Bohr able to explain the spectrum of hydrogen? And see, he was awarded the Nobel Prize for his work. How could Bohr explain the spectrum of hydrogen? Yes, please. I have done it in the previous class. Bohr ने हाइड्रोजन का स्पेक्ट्रा कैसे एक्सप्लेन किया था? Who is going to tell me? Yes, please. So electrons revolve around the nucleus in definite energy levels, which we do not call as orbits, we call them as shells. And second point, as long as electron remains in a shell, its energy remains constant. That's why the energy levels or energy shells, they are called as stationary states. Related with these points, anybody wants to ask anything? Please, you have to be a bit interactive in this class. For the first time, we are having this sort of the class. So are the 2 points clear?
Yes, sir.
Yes, sir.
Yes,
I
sir.
move forward now. Yeah. The gain or loss of energy occurs within the shells only due to jumping of electrons from one shell to the another. Right? So if electron jumps from one shell to the another, there will be loss of energy. And that I have told you, electron absorbs a packet of, ye dekho, H plus H nu. So electron present N equal to 1 in the lower energy level. Yeah. So here the electron is present in the lower energy level. It absorbs this packet of energy and it jumps to the second energy level. And what is this higher energy state called as?
Excited state.
Excited state.
This higher energy state is called as excited state. And then electron from the second energy shell, it jumps back to the first energy shell and it gives out the same energy, and this energy forms lines in the spectrum. Clear?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Then was the angular momentum. Angular momentum, that is MBR of an electron, is some whole number multiple of h over 2 pi. एंड जो क्वांटम नंबर वर्ड है ये अगले एटॉमिक मॉडल में आएगा, प्लीज डोंट कंसीडर इट. So angular momentum is a whole number multiple of h over 2 pi where n can have values 1, 2, 3, 4 and so on. Applications of Bohr's atomic model. It gave us the radius, it gave us the energy of the shell, and you can also calculate the wave number जो हमने Rydberg formula से किया था. ये सारी calculations की मैंने आपको values दी हुई हैं. I've told you the values. Now these are the energies जो हमने, if you remember, it was 1, 3, 1, 2 in the first shell, second shell, third shell, fourth shell and fifth shell. So I told you the different energy shells, they have some definite, और क्या word use किया था? Definite and discrete values of energy. And you are finding that the energy, it varies discontinuously. And that's what we talk about quantization. That's what we talk about, the quantization of energy. Then we came to the defects in the Bohr's model. So just go through this point. According to the Bohr, radiation results when electron jumps from one energy level to the another energy level. But he did not explain how this radiation occurs. ठीक है कि इलेक्ट्रॉन एक शेल से दूसरे शेल में जाता है तो there is radiation of energy, but how this radiation of energy occurs was not explained. It could only explain the spectrum of hydrogen, not the multi-electron atoms. Bohr explained the spectra of hydrogen and hydrogen-like particles, but it could not explain the spectra of poly-electron atoms, multi-electron atoms. So atoms which have more than one electron, their spectra, it could not be explained on the basis of the Bohr's atomic model. Right?
Yes, sir.
Then, if a substance which gives line spectrum is placed in magnetic field, the lines of the spectrum, they get split into a number of lines. So this is the spectra in absence of magnetic field. You are getting a single line. But when the same spectra is studied in presence of magnetic field, this single line, it splits into large number of lines. Now this splitting up of a single line into large number of lines in presence of magnetic field is called as Zeeman effect. And if in place of magnetic field I do electric field here, then this will be called as, what was the name?
Stark's effect.
Stark effect. This is about the Stark effect. So now we are moving on to the two next things. That is the last point I told you, Bohr could not explain the de Broglie concept and it could not explain the Heisenberg's uncertainty principle. Understood or not? So now this was about the different things which I wanted. Anything you want me to show on the screen which I could not show you on the whiteboard there, you can talk to me today. Should I move on now?
Yes, sir.
Yes, sir.
So write down developments leading to Bohr's atomic model. Developments leading to the next model, which is the quantum mechanical model. Can you see the whiteboard?
Yes, sir.
Okay. So now we start with the last of the models, but we are not reaching that model. No, we are between a period between the Bohr model and the next model. So it is developments leading to the quantum mechanical model. Quantum mechanical model, or we also call it as wave mechanical model. तो फर्स्ट सबसे पहले कौन सा एटॉमिक मॉडल किया था हमने?
Thomson atomic model.
After Thomson,
Rutherford.
after Rutherford.
Bohr.
Now tell me what happened between the Rutherford and the Bohr model? What happened between the Rutherford and the Bohr model? We studied about the black body radiations. We studied about the photoelectric effect. Then we studied about the spectra, that is the emission and the absorption. So Rutherford model could not explain the spectra of the elements. So then we discussed the Bohr model. Bohr model could explain the stability of the atom. And what was its second achievement?
He explained the spectra of hydrogen.
It could explain the spectrum of hydrogen. Then we saw the drawbacks of the Bohr's atomic model. And the major two drawbacks were it could not explain the de Broglie concept and it could not explain the Heisenberg's uncertainty principle. So now we are going to discuss about the de Broglie concept and the second one, Heisenberg's uncertainty principle. Right? So I am going to start first with the de Broglie concept. So write down de Broglie concept of I'm telling you a new word now, duality of matter. De Broglie concept of duality of matter. What do I mean by duality of matter? That is, the matter has wave as well as particle nature. Matter is wave as well as particle. So let us start with it. Everybody has written it. De Broglie concept.
Excuse me, sir.
Yes.
डेवलपमेंट्स के अंडर लिखना है.
हाँ, डेवलपमेंट्स इज द मेजर हेडिंग और उस मेजर हेडिंग के अंदर सब ए मतलब सब हेडिंग ए is the de Broglie concept of duality of matter.
Okay.
Right?
Yes, sir.
Now what we are going to see is how de Broglie concept was a setback to the Bohr's atomic model. जो Bohr atomic model है वो de Broglie का जो concept है which I am about to discuss, it could not explain it. So there is a small derivation related to it. First, I will be showing it in my own hand and then I will be showing you the slide also. So I'm starting with this concept of de Broglie concept of duality of matter, where matter is being considered as a wave. Wave means?
Continuous.
And particle means?
Discontinuous.
Discontinuous. तो de Broglie ने बोला था कि जो मैटर है उसके अंदर ये दोनों ही नेचर्स पाए जाते हैं and how they are present and how they are related, that will be seen with this very equation. So I am going to show you the derivation of the de Broglie equation. There is a de Broglie equation. It's a very simple. देखना इसको. Now it says E is equal to, बता रहा मुझे, E is equal to, याद है?
Yes, sir.
So E is equal to h nu. H nu I can write as hc by lambda. And if I am talking about lambda, that is wavelength, automatically here I am talking about which character?
Wave correct.
Wave character. Then I have another equation, E is equal to mc square. Have you heard about it?
Yes, sir.
Sir.
क्या बोलते हैं इस इक्वेशन को? It is Einstein's mass energy relation. And as here mass is being talked, so here it is talking about
Particle.
if I consider this equation as 1 and this equation as 2. In equation 1 and 2, are their left sides same?
Yes, sir.
So their right sides can be equated.
Yes, sir.
It becomes hc by lambda is equal to mc square. This c and one of the c cancels from here. And here I get lambda is equal to h over what is lambda here?
Wavelength.
Wavelength.
और इसको हम अब de Broglie wavelength बोलना स्टार्ट करेंगे. I will come to that point. H is
Planck constant.
what is m?
Mass.
Of
अब मुझे बताओ ये
particle.
किसका मास है इस टाइम यहाँ पे? इस
Particle.
इक्वेशन किसका मास है ये?
Particle.
And what is that particle?
Quanta.
Okay, make it better. Quantum.
Photon.
Photon. किसने बोला ये?
Me. Reeth.
कौन?
Reeth.
Preet, that's very nice. That's very nice. अब देखो अगर मैं C की बात कर रहा हूं तो what is C?
Speed of light.
Speed of light. और अगर लाइट है तो आपको पता है लाइट का जो क्वांटम है दैट इज फोटोन. So for the time being जो ये equation है, this is talking about light, that is photon. So let's take it as equation number 3. In equation 3, if m is replaced with the mass of the particle, and c is replaced with the velocity of the particle, then this equation lambda is equal to h by mc gets modified as lambda is equal to h over अब लेफ्ट में देखो जो इक्वेशन है दैट इज ओनली एप्लीकेबल टू अ फोटोन, दैट इज द लाइट. बट अगर मैं इसको रिप्लेस कर दूं, if I replace m with the mass of the particle and c को replace कर दूं with the velocity of the particle, then this equation gets modified as this, and this equation is called as de Broglie equation. Now जो right side वाली equation है, this is applicable to all material particles. ये फोटोन के लिए भी एप्लीकेबल है, इलेक्ट्रॉन के लिए भी एप्लीकेबल है. इट इज एप्लीकेबल टू अ क्रिकेट बॉल, इट इज एप्लीकेबल टू अ मूविंग फुटबॉल, or it may be applicable to a car running on a road. This equation is called as de Broglie equation, where lambda is the de Broglie wavelength, h is the Planck's constant, m is the mass of the particle, and v is the velocity of the particle. Am I understood here? Yes or no?
Yes, sir.
एक बार देखो, शुरू से देखो इसको. E is equal to h nu, that is hc by lambda, that is the wave character. Then according to the Einstein mass energy relation, E is equal to mc square, where m is the mass of the particle and c is the speed of the light, which emphasizes the particle character. In equation 1 and 2, their left sides are same, so I equate their right sides. So it becomes hc by lambda is equal to mc square, which becomes this. अब इस इक्वेशन में मैंने m को रिप्लेस कर दिया विद द मास ऑफ द पार्टिकल और c को रिप्लेस कर दिया विद द वेलोसिटी ऑफ द पार्टिकल, and my this equation now gets modified as lambda is equal to h by mv. करना ये नोट कि डन?
Sir, please.
हाँ,
Done.
डन है.
Yes, sir.
Yes, sir.
No, sir.
करो जल्दी से. हो गया? Okay.
Yes, sir.
Yes,
Done.
sir.
Yes, sir.
So lambda is equal to h by mb. Now this is a new equation. It relates the wavelength of a particle with the mass and the velocity. Now, अब देखना इसको. Lambda is equal to h by mb. अब मुझे बताओ m into v is also called as
Linear momentum.
linear momentum. So I write it as lambda is equal to h over p, where p is
Linear momentum.
the momentum, and you know that momentum is a property of a मोमेंटम तो एक पार्टिकल ही पोजेस करेगा. अ मूविंग कार हैज अ मोमेंटम, ठीक है. अ रनिंग एथलीट हैज अ मोमेंटम. अ मूविंग इलेक्ट्रॉन विल हैव अ मोमेंटम. So momentum is the property which emphasizes the particle character, and lambda is the wave character, and this is a constant. Agreed or not?
Yes,
Yes,
sir.
sir.
So can I say wave character is inversely proportional to the particle character? Wave character is inversely proportional to the particle character. दोबारा देखो इसको. Lambda is h by mb, where I say lambda is the wavelength, automatically emphasizes the wave character. H is a constant, p is the momentum, and momentum is a property of a particle. So from where I gave you the thing that according to the de Broglie concept, the wave character and particle character are inversely proportional. So that is, if a substance, if an object has a high particle character, it will have a low wave character. अब बताओ इलेक्ट्रॉन का पार्टिकल कैरेक्टर कम है या ज्यादा है? यार ये पार्टिकल कैरेक्टर किस चीज से बन रहा है? मास इनटू
velocity.
अब बताओ मास ऑफ द पार्टिकल इज 9.1 into 10 raised to power minus 31 kg. अब बताओ दिस मास इज लो और हाई?
Low.
इट्स वेरी लो. तो इसका मतलब है इलेक्ट्रॉन का पार्टिकल कैरेक्टर विल बी वेरी वेरी लो. और अगर इलेक्ट्रॉन का पार्टिकल कैरेक्टर बहुत लो है, इट मींस इलेक्ट्रॉन का जो वेव कैरेक्टर है दैट इज वेरी वेरी हाई. Now go the opposite. Now I have a moving car, and suppose that moving car has a mass of 2000 kg. तो बताओ इस मूविंग कार का जो पार्टिकल कैरेक्टर है वो कम है या ज्यादा है?
Zada.
Other.
तो मूविंग कार का जो पार्टिकल कैरेक्टर ज्यादा है, तो इसका मतलब है मूविंग कार का जो वेव कैरेक्टर है दैट विल बी
वो लो हो जाएगा.
very low. Are you able to understand what I'm trying to tell?
Yes, sir.
Yes.
ठीक है. So अब बताओ तुम्हारे को इस स्क्रीन के ऊपर डुअल नेचर नजर आ रहा है मैटर का?
Yes, sir.
Yes, sir.
बिकॉज आपके सामने वेव कैरेक्टर भी लिखा हुआ है, पार्टिकल कैरेक्टर भी लिखा हुआ है, मास ऑफ पार्टिकल भी उसमें आ रहा है. तो कहीं ना कहीं व्हाट वी आर ट्राइंग टू टेल इज कि एवरी मटेरियल पार्टिकल इज डुअल. दैट इज इट हैज अ पार्टिकल एज वेल एज अ वेव कैरेक्टर. बट उसके अंदर पार्टिकल कैरेक्टर ज्यादा है या वेव कैरेक्टर ज्यादा है, they are inversely related by this equation called as de Broglie's equation. Am I understood?
Yes, sir.
Yes, sir.
So what did de Broglie say? अब de Broglie ने इस इक्वेशन के बाद एक हाइपोथेसिस दिया. He gave a statement and he said that all material particles in motion have a wave character. All material particles in motion have a wave character. ढंग से इस लाइन को पढ़ो. It says any material particle चाहे वो photon है, चाहे वो electron है, चाहे वो cricket ball है, चाहे वो moving car है, चाहे वो running athlete है, चाहे वो a football in the air, any material particle. But जब वो material particle किस चीज में होगा?
Motion.
Motion.
In all material particles in motion have a wave character. अब देखो, a cricket ball, is it a material particle?
Yes, sir.
अब आपके पास एक क्रिकेट बॉल है. अब अगर वो क्रिकेट बॉल स्टेशनरी है, मोशन में नहीं है, so that cricket ball is only a
Particle.
Particle.
What अगर वो क्रिकेट बॉल मोशन में आ जाती है, now this very cricket ball in motion will also develop a
Wave.
Wave.
wave character. So मुझे बताना, a running car is a particle, is a wave, or is it dual?
Is it it's dual.
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 A stationary car.
Dual.
Particle.
And what about the nucleus? Nucleus, particle, wave या dual?
Particle.
Particle because nucleus has a mass, but it is never in a state of motion, so a nucleus will always be treated as a particle. And what about electron?
Dual.
Dual.
Electron is dual, that is because it is always in a state of motion. और मैंने आपको प्रूव किया है कि इलेक्ट्रॉन का जो पार्टिकल करेक्टर है वो बहुत लो है, and as the particle character is very low, electron has a very significant wave character.
Wave character.
Could you get something out of it or not?
Yes.
Yes.
Okay. No. I'm just giving you a example. So I am going to compare two bodies here. Here I will be taking an electron, and electron for me represents a microscopic particle. And on this side, I have a cricket ball, which is a
Macroscopic particle.
macroscopic particle. Now, I'm going to calculate the wavelengths of both, right? So, suppose electron is moving with a speed of 60 meters per second. Okay or not?
Okay, sir.
And cricket ball is also moving with the same speed. The mass of the cricket ball, I assume it to be suppose 100 grams, that makes it 0.1 kg. And mass of electron we all know is 9.1 into 10 raised to power . यहाँ तक क्लियर हो रहा है आपको?
Yes, sir.
Yes, sir.
I have two different bodies moving with the same speed. ठीक है? ठीक है, तो I have electron as well as a cricket ball moving with the same speed, and now I'm going to calculate their what?
Wavelength.
Now I'm going to calculate their wavelengths, and after I give you the values of the wavelengths, you are going to talk to me. ठीक है? So lambda is equal to h over mv. This is 6.6 into 10 raised to power minus 34. Mass is 9.1 into 10 raised to power minus 31, and velocity is 60. Clear? And this value comes to be around this 10 raised to power minus 5 meters. Then I move to the another side. Lambda is equal to h over mv. That is 6.6 into 10 raised to power minus 34. Mass is 0.1. Velocity is 60. This value roughly comes around 10 raised to power minus 34 meters. Okay or not?
Yes, sir.
Yes, sir.
Yes, sir.
अब आपके सामने ये दोनों वैल्यूज हैं, दोनों पार्टिकल्स की मैंने लैम्डा कैलकुलेट की है. Now what inference, what conclusion can you make out of it?
So lesser the mass, more the velocity. More the wavelength.
मुझे बताओ इन दोनों वेलोसिटी में से which velocity is measurable?
Cricket ball, sir.
According to me, the velocity of this wavelength of the cricket ball is almost you look at the values. It is 10 raised to power minus 34. इतनी छोटी वैल्यू है कि जो भी मैं इंस्ट्रूमेंट यूज करूंगा वो इंस्ट्रूमेंट इस वेवलेंथ को स्टडी ही नहीं कर पाएगा. एग्रीड और नॉट?
Yes.
Yes, sir.
What I find that the wavelength of the electron, which is quite significant as compared to the wavelength of the cricket ball. So tell me, the de Broglie concept is more applicable to the microscopic particle or macroscopic particle?
Microscopic.
So जो हमने ये de Broglie concept किया है, you know that this de Broglie concept is applicable to all material particles. What it holds significance only to microscopic particles, because macroscopic particles के अंदर जो उनका particle nature है, that is very high, and because of that their wave character is negligible. Whereas when an electron will be in motion, it will have a very high, very significant wave character. So with this very example, I have tried to justify to you that the de Broglie concept of duality of matter is applicable only to
Microscopic.
microscopic particles like electrons, protons, etc., photons, etc. It is not applicable to a football in the air or a cricket ball or a moving car or a running athlete. So because उनका mass बहुत ज़्यादा है, तो जब वो move करते हैं, तो wave character is negligible. Please have a look at this and talk to me. कर लिया नोट ये?
Yes, sir.
Yes, sir.
अब इसके नीचे लाइन लिखो. The de Broglie concept of duality of matter, de Broglie concept of duality of matter is applicable only to microscopic particles.
Please repeat from the starting.
The de Broglie concept of duality of matter is applicable only to is applicable only to microscopic particles. तो हमारी डे टू डे लाइफ में जो पार्टिकल्स हम यूज कर रहे हैं उनको इतना ज्यादा ये मैटर नहीं करता. So a cricket ball is more of a particle or a wave?
Particle.
So cricket ball is a particle whether it is in rest or is in motion. Motion, it will have a wave character, but that wave character you can yourself see is negligible. Right?
Yes, sir.
Whereas an electron in motion will have a very significant wave character. अब आपने मुझे ये बताना है कि जो ये मैंने आपको पॉइंट बताया है कि जो डी ब्रॉगली कंसेप्ट है, इट इज एप्लीकेबल ओनली टू द माइक्रोस्कोपिक पार्टिकल्स. हाउ विल दिस अफेक्ट द बोहर्स मॉडल? आप अपने सामने देखो, आपके सामने जो ये मैंने कैलकुलेशन करके दिखाई है, आई हैव रिटन बिलो द इलेक्ट्रॉन इट्स वेव कैरेक्टर इज सिग्निफिकेंट. अब जो ये सिग्निफिकेंट वेव कैरेक्टर है, हाउ विल इट अफेक्ट बोहर मॉडल, और बोहर मॉडल का कौन सा पॉस्टुलेट है जिसको ये हर्ट करेगा? देखना, what did Bohr say? Around the nucleus, electrons revolve in
Fixed orbit.
he said that around the nucleus electron revolve in fixed circular paths, and he was so much sure about this कि उसने तो हमें इन सर्कुलर पाथ के रेडियस भी कैलकुलेट करा दिए. इफ यू रिमेंबर,
Yes, sir.
हमने फॉर्मूला किए थे ना, हाउ टू कैलकुलेट द रेडियस ऑफ द nth शेल.
Yes, sir.
And after I have studied the de Broglie concept, how do I look at the things is like this. Am I understood here or not?
Yes, sir.
Because de Broglie ने बोला electron is a microscopic particle and during motion it has a significant wave character. So there is no chance of the electron revolving in
Circular orbit.
because electron during motion will be a wave and a wave cannot undergo a circular motion. So by keeping the de Broglie concept in mind, Bohr's postulate of fixed circular paths is ruled out.
Excuse me, sir.
Yes.
So वो इलेक्ट्रॉन वेव लाइक मतलब कैरेक्टर शो करेगा, बट ये तो उसके सर्कुलर पाथ हैं, तो ये कैसे शो करेगा?
दोबारा बोला.
जो सा इलेक्ट्रॉन आपने बोला वो वेव लाइक मतलब कैरेक्टर शो करेगा, बट ये तो उसके फिर पाथ है, तो वो क्यों ऐसे आपने दिखाया?
जो इलेक्ट्रॉन क्या करेगा?
इलेक्ट्रॉन जो सा होता है वो मोशन में मतलब वेव कैरेक्टर शो करता है, तो ये आपने पाथ को क्यों ऐसे ड्रॉ करा?
जब इलेक्ट्रॉन, अब ये वेव कैरेक्टर शो किया ना जो राइट साइड में, जिसको मैं पर्पल में कर रहा हूं, दिस इज द वेव कैरेक्टर. वेव ऐसे ही मूव करती है. हमने किया ना वेव क्रेस्ट एंड ट्रफ.
यस.
तो वेव विल बी मूविंग इन अ क्रेस्ट एंड अ ट्रफ. सो अगर वो क्रेस्ट और ट्रफ में मूव करे, देन हाउ कैन वी से दैट द इलेक्ट्रॉन इज रिवॉल्विंग इन द फिक्स्ड सर्कुलर पाथ?
नो सर, यू सेड दैट कौन सा इलेक्ट्रॉन है वो वेव कैरेक्टर शो करेगा, बट ये तो उसका ऑर्बिट है फिर.
तो उस ऑर्बिट के अंदर इलेक्ट्रॉन रिवॉल्व कर रहा है ना.
यस.
तो इलेक्ट्रॉन, अब बोहर ने बोल दिया शेल होते हैं विच आर सर्कुलर, बट हमने देखा कि भाई इलेक्ट्रॉन तो सर्कुलर पाथ में रिवॉल्व भी नहीं कर सकता. So अगर इलेक्ट्रॉन एक सर्कुलर पाथ में रिवॉल्व नहीं कर सकता, then there is nothing called as fixed circular paths. Understood or not?
Yes.
तुम क्या देखो, हमने बोला है, जो बोहर ने बोला था कि इलेक्ट्रॉन्स रिवॉल्व इन फिक्स सर्कुलर पाथ, जिसको हम शेल बोलते हैं, ठीक है। बट अब आप अपने सामने देखो, बिकॉज इलेक्ट्रॉन ड्यूरिंग मोशन हैज अ वेव कैरेक्टर, सो इलेक्ट्रॉन फिक्स सर्कुलर पाथ में रिवॉल्व नहीं कर सकता, और एज अ रिजल्ट जो बोहर का मॉडल है दैट इज ऑल गॉन। उसने इलेक्ट्रॉन की वेलोसिटी भी मेजर करा दी, उसने इलेक्ट्रॉन की एनर्जी भी मेजर करा दी, इलेक्ट्रॉन का रेडियस भी मेजर करा दिया, बट सडनली वी केम टू नो the circular path he has been talking about actually is not there.
Okay.
Does everybody get me?
Yes, sir.
Yes, sir.
Yes, sir.
तो अब मेरी लैंग्वेज सुनना। After I have discussed the de Broglie concept with you, the conclusion I have made is electron being a microscopic particle during motion has a very significant wave character. And as it has a very significant wave character, so it means electron has to be considered as a wave. So while the electron is revolving around the nucleus, it cannot revolve in fixed circular paths. It will be revolving in the form of the waves. And as a result, the Bohr's concept of the fixed circular path is ruled out. So there is nothing called as fixed circular paths around the nucleus. The things are different. अब वो चीजें कैसी होंगी, that will be given by the next model.
Excuse me, sir.
Yes.
So sir, इसका मतलब ये हुआ कि वहाँ पे कोई शेल नहीं होंगे, सिर्फ इलेक्ट्रॉन एक सब मतलब फिक्स पाथ में रिवॉल्व करेगा बिना शेल
कुछ
के।
अभी तुम वो भुला दो, जो नेक्स्ट मॉडल है दैट इज गोइंग टू चेंज द थिंग्स ऑल टुगेदर। ये सर्कुलर पाथ नाम की चीज ही खत्म होने वाली है अब।
Okay.
There is nothing called as a circular path. Things are altogether different when we come to the quantum mechanical model. वो क्या चीज है वो मुझे नहीं पता, बट व्हाट आई हैव रूल्ड आउट इज कि भाई बोहर मॉडल ने जो हमें सर्कुलर पाथ की बात की है, दैट इज नॉट देयर।
Okay.
एवरीबॉडी गेट्स इट?
Yes, sir.
कोई क्वेश्चन?
सर अभी आपने जो लास्ट लाइन बोली थी वो रिपीट कर दो।
मैंने लिखवानी है स्टेटमेंट, वो
ओके सर।
मैं दोबारा से बोल देता हूं, तो लिखो इसको। अकॉर्डिंग टू द डी ब्रॉगली कंसेप्ट, according to de Broglie concept, electron being a microparticle, electron being a microscopic particle in motion has a significant wave character. According to the de Broglie concept, electron being a microscopic particle in motion has a significant wave character. As a result, electron around the nucleus, cannot revolve in fixed circular paths.
सर दोबारा बोलना एक बार।
मैंने सारा लिखा हुआ व्हाइट बोर्ड पे, कांट यू सी इट? व्हाइट बोर्ड नजर आ रहा है ना?
सर एज अ रिजल्ट से।
मैं दोबारा से बोल रहा हूं, अकॉर्डिंग टू द डी ब्रॉगली कंसेप्ट, इलेक्ट्रॉन बीइंग अ माइक्रोस्कोपिक पार्टिकल इन मोशन हैज अ सिग्निफिकेंट वेव कैरेक्टर. As a result, it cannot revolve in fixed circular paths. So it cannot revolve in fixed circular paths. So Bohr's concept of fixed circular paths is ruled out. Bohr's concept of fixed circular path is ruled out. Is it done?
Yes, sir.
ये पॉइंट क्लियर हुआ ना? डी ब्रॉगली का सारा कंसेप्ट हमने डिस्कस कर लिया और वो डी ब्रॉगली के कंसेप्ट से कैसे हमारा बोहर मॉडल वाज अ फेलियर. क्लियर टू एवरीवन?
Yes, sir.
Yes, sir.
अब बताओ, डज एटम लुक लाइक दिस? तो जो हमारा एटम है, इट डज नॉट लुक लाइक दिस. अभी तक मुझे कुछ ऐसा लग रहा है. दैट्स व्हाट आई सी. But what that will be done by the next model. So from today onwards, there is nothing called as an orbit. There is nothing called as a circular path called as energy shell. No doubt energy shell is there, but that energy shell by no means is circular. Right है? अब देखो, तुम लोग हमेशा ये बात करते हो कि सर अगर बोहर मॉडल फेल था, रदरफोर्ड मॉडल फेल था, थॉमसन मॉडल फेल था, देन व्हाई वी आर डूइंग इट. अब तुम अपने आप इमेजिन करो, अगर मैं डायरेक्टली आपको ये कराना स्टार्ट कर दूं क्वांटम मैकेनिकल मॉडल, यू विल नॉट बी एबल टू अंडरस्टैंड हाउ द थिंग्स हैव गॉन. एंड आफ्टर डूइंग ऑल दिस स्टफ, नाउ यू विल बी एबल टू सी द एटम मोर क्लियरली. राइट है कि नहीं? करें आगे कंटिन्यू. सो लिखो अब, न्यूमेरिकल्स बेस्ड ऑन डी ब्रॉगली इक्वेशन. न्यूमेरिकल्स बेस्ड ऑन द डी ब्रॉगली इक्वेशन. अब हमने डी ब्रॉगली इक्वेशन में कुछ न्यूमेरिकल्स ट्राई करने हैं. What is de Broglie equations? Lambda is equal to H over mv. Where lambda is the de Broglie wavelength, H is the mass of the this Planck's constant, m is the mass of the particle, which most probably will be a microscopic particle, and v will be the velocity
of particles.
So write down the question number 1. Calculate the wavelength of a cricket ball of mass 0.1 kg moving with velocity of 10 meters per second. Calculate the wavelength of a cricket ball of mass 0.1 kg moving with velocity of 10 meters per second. जब आपने डी ब्रॉगली इक्वेशन यूज करनी है, प्लीज मेक इट अ पॉइंट, मास हैज टू बी इन केजी.
6.6 into 10 raised to minus 33.
जल्दी से करो वैल्यूज पुट. इट्स अ वेरी सिंपल, ज्यादा कैलकुलेशन है ही नहीं है इसमें. सो लैम्डा विल बी इक्वल टू 6.6 into 10 raised to power. मास ऑफ द पार्टिकल मैंने आपको दिया 0.1 and the velocity of particle दी 10. So this 0.1 and 10 will cancel out and my answer becomes 6.6 into 10 raised to power minus 34. अब अपने आप देख लो, एक क्रिकेट बॉल है और उसकी आप वेवलेंथ देखो -34 है, which is definitely insignificant. So again emphasizing my point, The de Broglie concept is not meant for macro particles. It is meant only for
Extraparticles.
microscopic particles. Should we start with question number 2 now?
Yes, sir.
Yes, sir.
Go calculate the mass of a photon moving with a having a wavelength of 3.6 angstroms. Calculate the mass of a photon having a wavelength of 3.6 angstroms. M निकालना है आपको, लैम्डा आपको गिवन है, H प्लैंक्स कांस्टेंट यू नो, सारा का सारा क्वेश्चन किसके ऊपर आ गया?
So
What will be
velocity.
the velocity?
Velocity.
3 into 10 power 9.
So lambda is equal to H by mv. मुझे निकालना है mass, तो mass becomes H over lambda into V. H is 6.6 into 10 raised to power minus 34. Lambda कितना है?
6 into 10 raised to power minus 10.
3.6 into 10 raised to power minus 10, because 1 angstrom is equal to 10 raised to power minus 10 meters, and velocity will be taken as 3 into 10 raised to power 8, because as it is a photon, it will be moving with the speed of light. So the photon word will give you the velocity here. Right or not?
Yes, sir.
Yes.
So I have put up the values. Rest is all the calculation from where mass comes out to be 6.1 into 10 raised to power minus 29. What should be the unit of mass?
Kg.
10 raised to power minus 21 kg. Is it okay? Yes or no?
Yes, sir.
Yes, sir.
So next, two particles A and B are in motion. Two particles A and B are in motion. The wavelength of particle A is 5 into 10 raised to power minus 8 meters.
So can you please repeat the question?
Two particles A and B are in motion. Wavelength of particle A is how much? 5 into 10 raised to power minus 8 meters. Calculate the wavelength of particle B if its momentum is half of A. There are two particles A and B in motion. A की wavelength है 5 into 10 raised to power minus 8 meters. आपको B की wavelength निकालनी है, where we are telling you that calculate the wavelength associated with the particle B if its momentum is half of A. एंड कीप इन माइंड, यहां पर आपको एच कैलकुलेशन नहीं करनी है. यू विल मेक टू डिफरेंट इक्वेशंस. एक लैम्डा ए वाली इक्वेशन बनाओ, एक लैम्डा बी वाली बनाओ, और उनका रेशियो निकालोगे तो आपका प्लैंक्स कांस्टेंट कैंसिल आउट हो जाएगा.
सर किसकी रेशियो निकालनी है?
आई हैव टोल्ड यू, आप लैम्डा ए की अलग इक्वेशन लिखो, लैम्डा बी की अलग इक्वेशन लिखो. Which formula you are going to use?
लैम्डा इज इक्वल्स टू h अपॉन p.
हाँ ठीक है. So lambda a is equal to h over lambda b will be equal to h over. Am I okay here?
Yes, sir.
Dividing 1 by 2 और 2 by 1, तो बन जाएगा lambda a over lambda b. h और h कैंसिल हो जाएगा. It will become p b over, बिकॉज आपको पता है जो मोमेंटम है और वेवलेंथ है दे आर इनवर्सली रिलेटेड. ये देखो लैम्डा ए अगर यहां पर है तो ये उससे ऑपोजिट है. तो आप देखो ये लैम्डा ए है तो पी ए उससे ऑपोजिट है. ये आपका लैम्डा बी है तो ये पी बी उससे ऑपोजिट है. नो व्हाट इज लैम्डा ए? हाउ मच? 5 into
10 power minus 8.
लैम्डा बी मुझे निकालना है. अब मोमेंटम की बात करो. ही सेज calculate the wavelength associated with particle B if its momentum is half of A. तो अगर मैं A का मोमेंटम 2p मान लेता हूं, then what will be the momentum of B? ये देखो,
P upon.
because he says that momentum of B is half of A. So मैंने A का मोमेंटम 2p मान लिया, उसका हाफ आ गया p. और आप अगर A का मोमेंटम p मान लेते हो तो B का विल बिकम p by 2.
सर
ठीक है.
p एंड कैंसिल नहीं हो जाएगा?
हाँ तो कर रहे हैं ना अभी. So this p and this p cancels out. So lambda b will be 2 into 5 into 10 raised to power minus 8. Lambda b becomes 10 raised to power minus 7 meters. So if you are given two different situations, तो आप हमेशा दो अलग अलग इक्वेशंस बनाओ. देन अब आपको अगर मैं ये क्वेश्चन करने को देता तो आपने उसमें h की वैल्यू भी डालनी थी और उसकी कैलकुलेशंस करनी थी. इट वुड हैव बिकम वेरी टीडियस. बट मैंने देखो लैम्डा ए की अलग इक्वेशन बना ली, लैम्डा बी की अलग बना ली और उनका रेशियो निकाल के देन आई गेट द वेवलेंथ एज 10 raised to power minus 7 meters. ये समझ आया कि नहीं?
यस सर.
Yes, sir. Yes, sir.
अगला क्वेश्चन लिखना है. If the kinetic energy of the electron is 3 into 10 raised to power minus 25 joules. 3 into 10 raised to power minus 25 joules. Calculate the wavelength. Calculate its wavelength. Saksham is there in the class? सक्षम नहीं है ना? तो काइनेटिक एनर्जी कितनी दी है?
3 into 10 raised to minus 25.
और निकालनी है आपको वेवलेंथ. अब आपको पता है वेवलेंथ निकालनी है, अभी ये फॉर्मूला यूज होगा. यस और नो?
Yes, sir.
अब h आपको पता है, मास आपको पता है, आपको वेलोसिटी निकालनी है. अब वेलोसिटी निकालने के लिए आपको काइनेटिक एनर्जी की ये वाली फॉर्म यूज करनी पड़ेगी, है ना?
Yes.
तो आप यहाँ इलेक्ट्रॉन का मास डालोगे, फिर वेलोसिटी निकालोगे. सो आई एम गिविंग यू अ डायरेक्ट रिलेशन, बिकॉज अदरवाइज देखो, आप अपने आप देखो. फर्स्ट यू आर गोइंग टू कैलकुलेट द वेलोसिटी फ्रॉम हियर, फिर वेलोसिटी को आप यहाँ पुट इन करोगे. सो नाउ आई एम गिविंग यू एन एक्सप्रेशन, lambda is equal to h over so what is lambda here?
Wavelength.
H is the Planck's constant, m is the mass of the particle, and E is the kinetic energy. समझाया ये? So this is the formula to calculate the wavelength when you are given the kinetic energy of the particle. So you put up the values here, और आपकी जो wavelength है that will come as, कर लोगे values put?
Yes, sir.
तो ये प्लैंक्स कांस्टेंट आ जाएगा. 2 मास ऑफ द पार्टिकल इज 9.1 into 10 is power minus 31, एंड E की जगह आ जाएगा 3 into 10 is power minus 25, जहां से आपकी वैल्यू आ जाएगी 8967 into 10 raised to power minus 10 meters. जिसको आप अगर एंगस्ट्रॉम में लिखना चाहोगे तो इट विल बिकम 8967 एंगस्ट्रॉम्स. कुछ लग रहा है पता?
Yes, sir.
Yes, sir.
देखना, कैलकुलेट the last question. Calculate the de Broglie wavelength of an electron moving with 1% of the speed of light. Calculate the de Broglie wavelength of an electron moving with 1% of the speed of the light. Moving with 1% of the speed of light. कर रहे हो?
Yes, sir.
1% of the speed of light, that is 1/100 of 3 into 10 raised to power 8, that becomes 3 into 10 raised to power 6 meters per second. So rest is lambda 6.6 into 10 raised to power minus 34, 9.1 into 10 raised to power minus 31 into 3 into 10 raised to power 6. आंसर आ जाएगा 2.4 into 10 raised to power minus 10 meters. Okay. Okay or not?
Yes.
sir.
Yes, sir.
लिखना calculate, this question is a homework. Calculate the ratio between the wavelength of the electron. Sorry, calculate the ratio between the velocity of the electron and the velocity of proton if both are having the same wavelength. Calculate the ratio between the velocity of the electron and the velocity of the proton if both are having the same wavelength. Question आया clear ये?
Yes, sir.
So this is about the de Broglie. Now anybody can tell me 1 electron volts is equal to how many joules? बताया हुआ ना मैंने ये?
1.6 into
1.6 into 10 raised to power minus 19. So yeah, because we are talking about the kinetic energy, so electron volt is the electrical energy, and this is how it is related in joules. अब मेरी बात ढंग से सुनना. For your test on Friday, it is mostly numerical based. ठीक है? So numericals on the Planck's quantum theory, numericals on the photoelectric effect, numericals on the Rydberg formulae, numericals on the calculation of wavelengths, frequencies, and wave numbers. Right?
Yes, sir.
सर कितने क्वेश्चन हैं टेस्ट में?
1 hour का टेस्ट है, सब्जेक्टिव टेस्ट है, न्यूमेरिकल बेस्ड है. प्लीज कम प्रिपेयर्ड अकॉर्डिंगली.
सर सिलेबस कहाँ तक आएगा?
सिलेबस आएगा बोहर्स एटॉमिक मॉडल में जो रिडबर्ग फॉर्मूला है.
ओके सर.
ठीक है, बट आई एम क्लियरली बता रहा हूं, मैंने कोई थ्योरी के क्वेश्चन नहीं डाले हैं कि राइट द पोस्टुलेट्स ऑफ बोहर्स मॉडल, पोस्टुलेट्स ऑफ प्लैंक्स क्वांटम थ्योरी. Clearly telling you it is all numerical based. Please come properly prepared for that. Right?
Yes, sir.
Okay, see you all.